Hi students, good morning everyone. Welcome back to online classes. In the classroom, we have already solved from exercise 7.1 two problems. Now, question number 3. A particle moves along a line according to the law S of t is equal to 2t cube minus 9t square plus 12t minus 4, where t is greater than or equal to 0. First subdivision, at what time the particle changes direction? Second question, find the total distance traveled by the particle in the first 4 seconds. Third question, find the particle's acceleration each time the velocity is 0. At first, let us take the function s of t. To solve this problem, first let us take a solution. What is given? S of t. This is referred as the distance of a particle moved along a line. So S of t is equal to 2t cube minus 9t square plus 12t minus 4, where t is greater than or equal to 0. This is the condition. You remember always up to the end of this problem. Now, the first question is, at what time the particle changes its direction? That is, the particle starts moving. So, we want to find the velocity. If I take velocity is equal to 0, we will get the time t. So, v is equal to s dash of t. So, which is equal to differentiate this function s with respect to t. So, ds by dt. So, how to differentiate? 2 is a constant. If I differentiate t cube, it is 3t square minus 9 into, if I differentiate t square, it is 2t plus 12 into t differentiation is 1 and minus 4 is a constant. If I differentiate, it will be 0. So, velocity, that is v of t, is equal to s dash of t is equal to 2 3s are 6t square minus 18t plus 12. If I take, if velocity equal to 0, which implies 6t square minus 18t plus 12 equal to 0. There is a common number 6, so you take the common number out. So the equation becomes t square minus 3t plus 2 equal to 0. So which implies I can take this quadratic equation t square minus 3t plus 2 equal to 0. When I factorize this 2 and minus 3, if I take the factors 1 and 2, 1, 2 is 2, 1 plus 2 is 3, but here is minus, so take minus on both the factors. So the factor is t minus 1 and t minus 2 equal to 0. If I take separately, t minus 1 equal to 0, which implies t equal to 1. T minus 2 equal to 0, which implies t equal to 2. So when velocity equal to 0, the time taken at the particle is 1 second and 2 seconds. Now I want to check whether in these times the particle changes its direction or not. Now let us go. So to find that, let us take a tabular column. So take a tabular column and first of all draw a number line minus infinity to plus infinity, and here the minimum value it is given is 0, but I got t equal to 1 and t equal to 2, and these are the intervals. So first column take the intervals, and second column take these factors t minus 1 and t minus 2, and at last check the sign. Now interval, take the minimum number is 0 because t is greater than or equal to 0. So beyond 0 there should be no values for t. So since t is in seconds, let us take 0, comma 1 is the first interval. Then the next one is 1, comma 2. The last interval is 2, comma infinity. Now take a sample points and check in this whether it takes its positive or negative value. Now from 0 to 1, take a sample point as 0.5. Now substitute instead of t here. 0.5 minus 1 is minus 0.5, so it takes its negative value. 0.5 minus 2 is minus, minus minus plus. And 1, comma 2, here you can take a sample point as 1.5. So 1.5 minus 1 is positive, 1.5 minus 2 is negative, plus minus minus. And the last one is after 2 we can take 3 as a sample point. 3 minus 1 is 2, positive. 3 minus 2 is 1, positive, 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 positive. Now where it changes its direction. Look at these factors. Here minus, minus, no changes. Plus, minus, here the direction changes. Here plus, plus, no changes. So here we got the changes. So when t equal to 1 and t equal to 2, the particle changes its direction. Is the answer. So where it changes its direction, when t is equal to 1 second and t equal to 2 seconds, the particle changes its direction. Now let us go to the second subdivision. Second subdivision is to find the total distance. Total distance travelled by the particle. So to find the total distance, we can use the formula modulus of S of T1 minus S of Tc plus modulus of S of Tc minus S of T2. So let us take this formula. Now to find this, we want that when v is equal to 0, t is equal to 1, comma 2. But the question is, what is the total distance travelled the particle in 4 seconds? So the question is in the first 4 seconds. So let me take a number line, minus infinity, plus infinity. The minimum value for t is 0. When v equal to 0, we are getting t equal to 1, t equal to 2. And here we want to find first 4 seconds. So the maximum number is 4. So these are the 4 values we want to take. So substitute these values in the original equation. S of t is equal to 2t cube minus 9t square plus 12t minus 4. Now substitute S of 0. Instead of t, substitute 0. So it becomes 0 minus 0 plus 0 minus 4 equal to minus 4. Now find S of 1. 2 into 1 cube minus 9 into 1 square plus 12 into 1 minus 4. So which is equal to 2 minus 9 plus 12 minus 4. So minus 13 plus 14 is equal to 1. So S of 1 equal to 1. Now find S of 2 is equal to 2 into 2 cube minus 9 into 2 square plus 12 into 2 minus 4. So 8 2s are 16, 4 9s are 36 plus 24 minus 4. So 40 minus 40 is 0. So it is S of 2. S of 2 equal to 0. Then find the S of 4. So 2 into 4 the whole cube minus 9 into 4 the whole square plus 12 into 4 minus 4. So 4 4s are 16, 16 4s are 64, 64 into 2 is 128 minus 4 4s are 16, 16 9s are 144 plus 12 4s are 48 minus 4. So now 128 and 48, add these two numbers, 160 176. Take 176. And negative numbers are 144, 4. Add these two, 148. So subtract this, we are getting 28. So S of 4 is equal to 28. Now take the formula total distance is equal to modulus of. The first interval is 0, 1. Take the greater value minus smaller value. So S of 1 minus S of 0. So S of 1 minus S of 0. First interval plus next interval 1 and 2. Greater value is 12. Smallest value is 1. So S of 2 minus S of 1. Plus the last interval is 2 and 4. Greater value is 4. Smallest value is 2. So it is S of 4 minus S of 2. This is the formula. Now apply all the values. S of 1 is 1 minus S of 0 is minus 4. S of 2 is 0. S of 1 is 1 plus S of 4 is 28 minus S of 2 is 0. So it is equal to 1 minus of minus plus 4 plus modulus of minus 1 plus 28. Now remove the modulus and write 1 plus 4 is 5 minus 1. Modulus of minus 1 is plus 1 plus 28. So the answer is 29 plus 5 is 34. So the total distance traveled by the particle is 34 meter is the answer. Now third subdivision. Now third subdivision. Find the acceleration when v is equal to 0. Now when v is equal to 0. Now what is v? v is equal to ds by dt is equal to 6t square minus 18t plus 12. Now to find the acceleration is equal to v dash of t. So which is equal to s double dash of t. So differentiate s of t in 2 times. So which is equal to d square s by dt square. All are equal. So a is equal to, now differentiate this once again. So t square is 2t. 2 into 6 is 12. 12t minus t differentiate 1. So 18 into 1 is 18. Now to find when v equal to 0, t equal to 1 and t equal to 2. This is the previous result. So let us substitute instead of t equal to 1 and t equal to 2. So v dash of 1 is equal to. So in this function instead of t substitute 1. So 12 into 1 minus 18. 12 minus 18 is 6 minus 6. So v dash of 1 is equal to minus 6 meter per second square. Since it is the acceleration, the unit is meter per second square. Then v dash of 2. Now take this function and instead of t substitute 2. So 12 into 2 minus 18. So 12 2s are 24 minus 18. Once again it is 24 minus 18 is 6. So v dash of 2 is equal to 6 meter per second square is the answer. Thank you.